Alrighty, howdy folks. Uh, we are almost done with chapter 2. This is the last section in it. And for sure, we are done with all the multiple cash flows, the stuff that we were talking about. We are done with that. But we have a very interesting concept here of what is called compounding frequency. Okay, without much further ado, let's get on to what this compounding frequency stuff is all about. Now, so far, the interest rate was stated per year and the compounding period was also 1 year. Would you agree with that? We said John borrowed for 15 years at 10% compounded annually, right? But the truth is, the compounding period, it need not be the case. So the interest rate is given per year, that's possible, but the compounding period need not be 1 year. It could be 1 month or quarterly. That means every 3 months. Right? There are 4 quarters in a year, and so every 3 months you could have this thing compounded. And how about a minute? Could you compound something per every minute? Yeah. Could you compound every second? And what else? There's something called continuous compounding, right? Now, intuitively, we would think continuously compounding would mean there would be infinite number of periods. Man, that's bad, right? That's going to just blow up if you're compounding continuously. Okay, we'll talk about all of that stuff. For example, interest could be 1% per month and compounded monthly. That's a possibility. Or I could have, instead of saying 1% per month, I could have said same thing as 12% per month and compounded monthly. That's a possibility. And compounded daily. Now, one important definition here is a couple of them are very important. Nominal annual interest rate, or so R is the interest rate per year. Absolutely, we need to know this one because you remember whenever you try to buy a car and you try to get a loan, the dealership will say, "Oh, our APR is 7%," right? APR, annual percentage rate, is the nominal annual interest rate. So when they say 7% per year, that they are giving you the nominal annual interest rate. There's a little more complication to it so far as APR is concerned, but let's not go too deep into it. When they say, so all I'm saying is when a dealership quotes you some percentage, they are quoting you a percentage per year, and that is the nominal annual interest rate. And based on that, we can calculate the period interest rate. What is that? That is the I. This is the one that we've been using all this time, this I. And that is the interest rate per period of compounding. It just so happened that up until now, our rate, the period of compounding was 1 year. And the interest was also given for 1 year. So they both matched. But like I said, it need not be the case. So we need to clearly identify this thing as I, as the interest rate per period of compounding, not per year necessarily. Okay. So what is the period interest rate I? That is the nominal annual interest rate divided by number of compounding periods per year. That's interesting. So the period interest rate would be the interest rate per year divided by how many ever compounding periods exist in 1 year. Okay. Now, earlier when I looked at this interest could be 1% per month, I said you could state this 1% per month as 12% per year, right? So this 1% per month is the period interest rate I, because it is compounded monthly. However, if we said 12% per year, we can calculate the period interest rate to be 12% divided by 12, because there are 12 months, 12 compounding periods in a year. That turns out to be the same thing as this 1%. Okay. All right. Then those are two important definitions. And now let's look at a few problems. If $2,000 are invested in an account, what is the balance after 3 years when the interest rate is 12% per year compounded monthly, 12% per year compounded quarterly, right? Good. So let's try to identify. $2,000 is invested in an account. What does that represent? Would you agree that represents P? Good. What is the balance after 3 years? So we need to find F, the future value, with N equals 3 years, right? 3 years. And interest rate is 12% per year compounded monthly. How do we interpret that? 12% per year. That must be R, the nominal interest rate, right? Now, based on the nominal interest rate of 12% per year, we need to figure out what the monthly interest is or the period interest is. Similarly, for that same nominal interest rate of 12% per year, we need to figure out what the quarterly interest rate is, because this is compounded quarterly. If we do that, we are done. Cool. We have P equals 2000. Total time of investment is 3 years. I don't know if you notice, I'm not calling that as N, right? I'm calling it as total time of investment to be 3 years. Why didn't I do that? You'll find out. F is what? That's the question mark. So for case 1, 12% per year compounded monthly, nominal annual interest rate R is, would you agree, 12%? Yep, that's 0.12. Now, based on that, what is the compounding frequency here? Compounded monthly. So compounding frequency is monthly, which means number of compounding periods per year is what? There are 12 months, so 12. Okay. Now, what is the total number of compounding periods? That I'm calling as N. Okay. Isn't that the same as 3 years? No, it's not. Because there are 12 compounding periods per year and the total time of investment is 3 years, actually, the number of compounding periods is the 12 times 3. 12 per year times 3 years gives you 36 periods. Okay, that is going to be our N. Please make sure you understand this concept. And then period interest rate. Did we talk about period interest rate? R divided by the number of compounding periods. Nominal annual interest rate over number of compounding periods per year. So R happens to be 0.12, number of compounding periods happens to be 12. So 0.12 divided by 12 or 1%. So that's the interest rate per month. Good. Now, armed with all this piece of information, we can use our old formulas. What is that? P times 1 plus I to the N. P happens to be 2000. I happens to be the period interest rate is 0.01. And the total number of periods is 36. Cool. So that gives you $2,861.54. All right. Cool. Let's move on to the next part, part B, where the nominal annual interest rate is still 12%, right? Still 12% per year compound, second part, 12% per year compounded quarterly. That's the only difference. So let's see how that works. 12% compounding frequency is quarterly. How many periods? Compounding periods per year? 4. And so total number of compounding periods, because we have 3 years, investment time is 3 years, so 3 years times 4 periods per year, so that gives you 12 periods in this case. And the period interest rate is the nominal divided by the number of compounding periods per year, and so that should give us 0.03 or 3%. And the rest of the calculations is similar, p times 1 plus I to the n, but the numbers are slightly different. And this turns out to be 2851.52. This is 2851. And the previous one, let me go back, is 2861. Okay, 2861 as opposed to 2851. So there's about a $10 difference. Does that kind of make sense? We are compounding every 3 months, in this case B, but in case 1, we were compounding much more frequently every month. So there is a difference because of that. And in fact, the first one should be a larger number than this one because we were compounding much more frequently. Okay, with that, let's move on to the next one. A total of $50,000 is borrowed and repaid with 60 monthly payments, with the first payment occurring 1 month after receipt of the $50,000. The stated interest rate is 6% per year, compounded monthly. What monthly payment should be made? Now, this is a very interesting problem because it is very, very practical. Tomorrow, if you go to a bank and you try to get a loan, this is exactly the kind of calculations that they will make. How much are you borrowing? Maybe they will have taxes and interest and not interest, taxes and charges and fees and things like that added. But whatever it is, if the total thing that you're borrowing as a result happens to be $50,000 and you decide to pay it off in 60 monthly payments, or maybe you're buying a BMW or a Tesla for 50,000 and you're paying it off in 5 years, paying every month. And the first payment is 1 month after the receipt of that thing. So at t equal to 0, you're borrowing this, and t equals 1 month, you're paying your first payment, and t equals 2, you're making the same payment as you did in the first month. So every month you make the same payment. Okay. And so how do we deal with this? This is a problem of finding A in a uniform series given P. Would you agree with that? Every month, what should I pay? Same amount. So that means that is uniform distribution, and A is uniform series given P. P happens to be 50,000. I hope you agree with that. And total time of the loan is 60 monthly payments, right? 60 months. And nominal annual interest rate, or notice how this interest rate is stated as 6% per year. So R is 6% or 0.06. And compounding frequency is monthly. So number of compounding periods is 12. Would you agree? And period interest rate, let's calculate the period interest rate as R over this number of compounding periods, M. And so this is 0.06 divided by 12. So we got the period interest rate. The only thing is how many compounding periods in total. So that is the N, 60 months. And so that is the number of compounding periods, 60 periods, right? Cool. If they could have said 5 years, and if they had said 5 years, we would have said 5 years times 12 is 60 periods. Okay. Recall that P equals A times 1 plus I to the n minus 1 over I in this thing, And so we need to find A, and so we'll multiply by the reciprocal and plug and chug. Turns out to be $966.64. That's fairly realistic. Like if you borrow something and you're getting 6%, 6% would be really good. So you would be paying almost $1,000 every month for 60 months. So a quick calculation would be 60 months times 1,000 would be 60,000. So you borrowed 50,000, but you'd be paying close to 60,000. Okay. All right. On a 50, so that means on a 50,000, you're paying 10,000. Wow. Wow. Okay. Now we need to learn about a concept called effective annual interest rate. All right. What in the world is that? For a $1 investment at 12% annual interest rate compounded monthly, what is the future value after 1 year? Whoa. You invested, your P is just say $1. And the compound, and it is the nominal interest rate is 12% annual interest rate, and it is compounded monthly. If that is the case, what is the future value after just exactly 1 year? Good. Let's figure this out. P is $1. Total time of investment is 1 year. And F is what? Question mark. And A. Nominal annual interest rate is 12%. So compounding frequency is monthly. Compounding periods per year is 12. And therefore, total number of compounding periods would be, because we are talking about 1 year times 12 and 12 periods per year. So that is 12 periods. So N is 12 periods. Period interest rate is nominal divided by the number of compounding periods. So 0.12 divided by 12, which is 0.01. Okay. Now we need to find F, right? F is P times 1 plus I to the N. So plug 1 for P, 0.01 for I, and 12 for N. And when you do that, you get 1.1268. But so what? What's the big deal about this? The big deal about this is for $1 investment or loan, how much are you paying at the end of 1 year? 1.1268. But so for 1 year, shouldn't that be P times 1 plus I? You remember? And I is 12% per year. So in 1 year, on a $1, you should pay 1 times 0.12, right? So your interest should be only 0.12, but looks like it is actually 0.1268. There is that extra thing. And that is because this is being compounded monthly, right? And so the interest earned in 1 year, therefore, is 1.1268 minus 1, which is $0.1268. Okay. So that means the effective annual interest rate is 0.1268. That is the effective annual interest. They may quote you a number like 12% per year. What's your interest? Oh, 12% per year. Okay. What is the compounding frequency? We are doing it every month. Aha. So the actual rate I'm getting charged is 12.68%. No, 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 we're doing only 12. No, no. Effectively, you are being charged 12.68. Now, they would be truthful if they said our interest rate is 12% annually and we are compounding every year. Then what is your interest, effective interest? 12%. But if you're compounding monthly, then the annual interest is what is stated here is not the actual annual interest rate. That is the effective annual interest rate for all practical purposes, you are paying 12.68%. Cool. That's a very interesting concept. And so, how do you find effective annual interest rate? 1 plus R over M, the quantity raised to M, minus 1. What? See, this was 1 times 1, 1 that, times 1 plus R over M, right? R is the effective annual interest rate. M is the number of compounding periods raised to, there are 12 compounding periods in 1 year, raised to M minus 1. So the minus whatever you invested. That is the effective interest rate, where R is the nominal annual interest rate, M is the number of compounding periods per year. Cool? All right. Now, let's look at this. If the loan amount is $600,000 with two options, one, 7% per year compounded monthly over 30 years, or 6.625% per year compounded monthly over 15 years. Getting the picture? 7% per year compounded monthly over 30 years, or 6.625% compounded monthly over 15 years. Okay? And this is also a very realistic example. When you get a mortgage for your house, this is exactly the kind of terms that they will state for you. Okay, find the following. What is the monthly payment for plan one, right? For this guy. What's the monthly payment for plan two? And what is the effective annual interest rate for plan one and effective annual interest rate for plan two? Total interest paid over life of loan one and total interest paid for life of loan two. All very interesting questions. So let's get right onto it. A, you borrowed 600,000, so P is $600,000. Time of loan for this case, the first case, is 30 years. And nominal annual interest rate at this time is 7% per year. And compounding frequency is monthly. So number of compounding periods per year would be 12. Period interest rate is R over M, nominal annual interest rate R divided by the number of compounding periods per year, M. And so that is 0.07 over 12. I'm not figuring out what that is as a decimal, just leaving it as 0.07 over 12. And the total number of compounding periods is what? Aha! 30 years, and there are 12 compounding periods per year. So the total number of compounding periods, 30 years times 12 is 360 periods, right? Okay. Monthly payment. That's what we need to figure out. Now, we know P and we need to find A. So we'll invert the formula that we know and say A equals P times I times 1 plus I to the n over this. And so when you plug and chug, for I am plugging 0.07 over 12 and find this out, and n is 360. When you do this, you get $3,991.82. So you are pretty much paying $4,000 every month for 30 years. Okay. All right. So as a rough calculation, what would that be? 4,000 times 360. Yikes. That's a lot of money. 4,000 times 360. Now I'm curious. Times 360. What? 3991. I'm sorry. I'm just curious. times 360 is 1. Whoa, Nelly. I mean, if you just look at how much cash went out of your own hands, you know, uh, of course, time value of money, I'm not keeping that in. So if you just look at these payments, 360 on, it would be $1,437,055. $1.4 million. Even though you got a loan of only you got a loan of only 600,000, you're paying 1.4 million. Whew, interesting. Cool. Let's move on to the next one. Um, P is still the same. Time of loan is 15 years. Nominal annual interest rate, they were good and they reduced it from 7% to 6.625%. And compounding frequency is still monthly. And so the number of compounding periods per year is still 12. And the period interest rate is 0.06625 divided by 12. And that's the point, that's the thing. And compounding periods would be 15 years times 12, 180 periods. And monthly payment would therefore turn out to be, by plug and chug, 5,267. Okay. So that was close to 4,000 and this is 5,267. No wonder this is a little more, but out of curiosity, I want to punch in times 180. That turns out to be 948,232. 950,000. So for a loan of 600,000, you would be, from your pocket, you would be shelling out 950,000. Makes you think twice about whether you should get a 30-year loan or a 15-year loan, right? Anyways, so effective interest rate for plan one, we need to find this one. And you remember 1 plus r over m, the quantity raised to m, minus 1. So let's use that formula. And for plan 1, where the r was 7 and m was 12, excuse me, we have this, and that turns out to be 7.229%. So even though they said 7% per year, in effect, you are paying 7.229% per year. And for the second plan, a similar calculation. Even though they said 6.625, you are actually paying 6.830%. Okay. All right. Give me just half a second. I need to drink some water. Thank you. Total interest payment with plan one. Okay. So this is the thing. Just the monthly payment times total payment months minus the amount borrowed. So, right, just simply multiplying, you are paying an extra $837,000 on a $600,000 loan. Okay. Um, for this, you're paying $348,000 to $348,232.80 extra just on interest. Of course, over a period of 15 years, however, that's the extra you're paying. Cool? All right. Then we'll go to continuous compounding. If the nominal annual interest rate is R and is compounded continuously, what is the effective annual interest rate? Okay. Now, effective annual interest rate, the formula is 1 plus R over M to the M minus 1. Okay, what in the world is that? R is the effective annual interest rate. M is what? M is the number of compounding periods in 1 year, right? M is what? Number of compounding periods in 1 year. For monthly, M is 12. For quarterly, M is 4. For daily, 365. Okay. Now, for every minute, 365 days times 24 hours in a day. So 365 times 24, that would be M. But we are not even talking about that. We're talking about continuously compounding. So what is M? If you're compounding continuously, what is the value of M? M actually is infinity, right? Now, M is infinity. I shouldn't say M equals infinity. Mathematicians would just frown upon. What did you say? M equals infinity? You idiot. That's what they would tell me. They should say, you should say M approaches infinity. So M approaches infinity. Therefore, the effective annual interest rate, okay, man, just plug infinity for M. No, you cannot plug infinity, right? So how do we find this? Calculus. What? Yep, calculus 1. What? Limit. Oh, that stupid limit again. Yes, I know. So limit as m approaches infinity. That is how you find. So limit as m approaches infinity of 1 plus r over m to the m minus 1. Okay. Do you know what this limit is? Limit of 1 plus r over m to the m. Hang on, hang on. I can do math. Yeah. M as m approaches infinity, r over m goes to 0. So we have 1 plus 0. 1 plus 0 is 1. 1 raised to infinity. 1 raised to anything is 1. And 1 minus 1 is 0. Hey, effective annual interest rate is 0. No. What? Why not? That is because limit of 1 plus r over m to the m is not 1 as m approaches infinity. That thing about 1 r over m is 0 because m is infinity, and so as m goes to infinity, r over m goes to 0. That is not true. That 1 plus 0, something of the form 1 plus something, some minuscule amount raised to something that's going to infinity is not that. That is actually e raised to r. That e, base of logarithm, natural log. So natural log, the base e is defined as limit as m approaches infinity of 1 plus 1 over m raised to m, right? If this is 1, r is 1, then the limit would equal simply e. But since this numerator is r, it turns out that would be e to the r. Okay. And so the effective annual interest rate for compounded continuously is e to the r minus 1. Very important formula. Let's do a problem based on that. Semi-annual deposits. Semi-annual deposits. So you are depositing every 6 months, beginning with $500 and increasing by $100 with each subsequent deposit. Okay, so at 6 months, deposited 500. Later, increased it to $600 after 6 more months. Are made into a fund paying a nominal 10% per year compounded continuously. Nominal interest rate is 10% and it is compounded continuously. What will the fund amount to after 7 years? And what is the present worth equivalent of the total set of deposits? what is the equal semi-annual equivalent amount of the deposits? What is the equal semi-annual equivalent amount of the deposits? You know what that is talking about? We are doing 500, then 600, then 700, and so on. What if I wanted to just make the same payment? Something like 525, 530 every month, or 600 every month. Would that be the same? That's what they're asking for. Okay, let's do all of them. This is a composite series with, we are starting with a 500. So you can say increasing by 100 part, you can always look at it as everything is 500, 500, 500. That's a uniform. Now, on top of it, you have a 0, plus 0, plus 100, plus 200, plus 300, so on. So that's a composite series with A equals 500 every 6 months and G equals 100 every 6 months. Cool. Since deposits are made semi-annually, we have interest rate per 6 months, or what would be that? Deposits are being made every 6 months, right? So what is the interest rate for that, for that 6-month period? Well, you have a nominal interest rate of 10%, and that we need to divide by 2 because there are 2 periods in that. So we have interest rate per 6 months is 0.05. Okay. And the effective annual interest, compounding interest rate, is e to the r minus 1. So e to the 0.05 minus 1, and that turns out to be the effective compound interest rate. Cool? Okay. Now, total number of compounding periods, n, would be what? Would be 7 years times 2. We have already calculated the effective interest rate. Okay. So n is 7 years times 2 for 14 periods, which is 14 periods. And so we'll find P sub A due to A and due to the G using our good old formulas. We always had 1 plus I. Now we'll use I effective because that's the situation here. So when you do these numbers, you get 10,500. So depositing 500 and then increasing every 6 months and increasing it by 100, all of that gives you, has a present worth of $10,500. Cool. All right. And now the future worth of this is, we are simply projecting it to forward by n years. N happens to be 14. So that is $21,144.78. And the present worth is 10,500. And equal semi-annual equivalent amount A, we just take this guy and this part and figure out A. So P times I effective all of this over that. That's it. So that turns out to be, it is as though you are depositing $1,069 every 6 months, right? With that avoids the complication of 500 then, 600 later, 700 after that, and 800 after that. Instead of doing all that, every 6 months you could be paying only this amount. Cool? Did that make sense? Alrighty. Thank you.